Alright, so I'm gonna talk a little bit about the system that I made here. So I'm gonna talk a little bit about what is good, what it can go wrong, what we can improve, uh, what is not so good, and things like that. Okay. So let's take a look a little bit um, about the problem. So we have those two corners. Okay, that's are are welding on the containers. So for those who don't know, I'm talking about those type of containers. Okay, so each uh, each container has on the top and the bottom side has four of those corners, and here I design a mechanism that will try to lock automatically. Okay, so I approach this thing uh, by uh, by transferring the weight on the y-axis. Okay, so pay attention to y here. So I transferring the weight from the y to rotational force. Okay, uh, so let's take a little bit how I do that. Um, we have pretty much three components that I'm gonna talk a little bit about those, and let me try to explain a little bit how exactly it's done. Um, so let me change the transparency of this piece, and you probably can see inside. You also have uh, some. Uh, let, let me change it again. Okay, so you have inside. You have those type of meshes here, and you can also see the bottom piece. Um, the bottom piece is also have a inside geometry here. Okay, something like that here, and you probably can understand where I'm going with this type of design. So it's gonna be something like that. At the beginning, of course, you can install it on the container manually, I guess, or you can do it automatically, but I see no sense to do it like that. But anyway, let me change one more time the transparency, so it will work something like that. Um, so you have the bottom container, and you want to lock the top container automatically. Okay? So using its weight to lock, like I said, to transfer the weight from the y to a rotational force. Okay, so the first piece is gonna be something like that, and it's gonna be uh, probably something like that. Okay, so I'm gonna talk. Don't worry. I'm gonna talk more about a little bit the connection, what can go wrong, what is good, what we can improve, and things like that. Um, so we have like I said, the bottom piece here, something like that, and the top piece gonna be something like that. And when uh, when we try to install it on the first time on the bottom container, uh, it's gonna be something like that. Okay, so you're gonna move those pieces like that. The surface of this we're gonna touch the bottom of this corner fitting, or however you call it, and the bottom piece, the middle piece, I should say, will be something like that. Okay, so when you apply the force, you move slowly by slowly and probably understand what I mean by that, until the top piece of this bottom piece is touching those type of faces here. And when that is happen, you you already have the faces of, uh, of the middle piece. Let me change armament and the transform. So you have the faces of the middle piece touching with with, with this face of the corner fittings. And when this happens, it's, I can guarantee you, if you uh, follow the measurements of the what I did here, is will be something like that. So when that is happened, you have a 90-degree rotation of the bottom piece here. So that will be the first movement. So that will be probably, let's say, manual movement that you need to install it. And yeah, that's pretty much it. The the top piece, uh, you're gonna stay something like that. So let's take a look a little bit on those uh, uh, surface here. Okay, so you probably already know what I'm trying to achieve here. Okay, so you you have a on a so uh, I try to explain so many things on on the same time, but the first thing, when you try to assemble this mechanism, you probably are gonna have it like that. And when the top container is coming down, okay, so when the crane or uh, whatever is driving that top container, whatever you call it, or whatever it may be, um, is trying to uh, lower this container, okay, and eventually this surface and this surface we're gonna touch uh, as soon as possible here. And while those surface touching, you transfer you what I did here in the design. I transferred this uh, the weight of the container to rotate this piece. Okay, so it's gonna be something like that. Let me change the transparency so you probably can see a little bit better. So when the crane is trying to push this container, push it slowly by slowly, and you eventually move it, and move it. And I probably can change transparencies to that and that too, so you can see exact. Well, I'm not sure if you can see, but I can see. That's for sure. So it's gonna be something like that. Okay, so the container is lowering and this piece is rotating, and the more is lowering, again is rotating and rotating until you hit a 90 degree, which gonna be something like that. And of course that 90 degree is happening when when you hit this surface, and those this surface is touching. Okay, so when this is touching that and that, you have a perfect 90 degree, which eventually will lock it here in place. Well, at least that is the theory. Well, uh, what can go wrong? And well, I'm gonna talk a little bit about that too. Um, you like I said, that is the theory, but what are the things that can go wrong? So let's start a little bit um, with the gravity. So you probably are aware there's gravity on Earth. Um, so at the first thing, so the first thing I should say is uh, you have the gravity. Yeah, if you try to install it, let's say on 90 degree here, the gravity will probably pull this thing down. So you need to uh, solve that thing. Well, the way that I see it, you can do, for example, after you install it, you may change the geometry after it a little bit, so you can prevent the fouling of this bottom piece. You might also you might also do something like um, I'm not so sure exactly how to explain it, but something like a ball you have on this surface here. You have just little uh, a little ball here inside on this surface here, and on the interior you also have uh, how to call it um you let me find the right word here. So uh, uh, not so sure if you really understand what I mean. So you in this surface you try to uh, to make a hole, but not a complete hole, just something spherical, and in the inside it of this face here that I selected, um, you insert some type of metallic ball, and with some type of arc you try to to lock it. So you try to prevent it from falling. Okay, so that is the thing with that thing here, as I'm trying to explain. So where it probably gonna be the successful, let's say, or the desired uh, place that that thing it can be. So it will probably be gonna be something like here. So you need something like that. Okay, so I'm paying attention on the rotation here of this bottom piece, and you simple, let's see, well, it's the wrong rotation. um, okay, so something like that, and you try now to align this surface with this surface from the interior, and looking at this one here. So something like that. Okay, so where gonna be the right place to install that thing? Well, you might install it right here, or right here, or right here, or on this surface also. So that it might be a thing that you can have it in the design. Okay. Um, on the top surface, what can go wrong here on the top on the top uh, piece here? Okay, so let's imagine, well, like you have this in place now. I'm not so sure about the accuracy that that crane in might have. In the theory that was pretty good, but I'm not sure, like I say, what precision has that crane, or whatever it's driving the top container. Um, so you might also need to take that in consideration. So let me explain what I want to to do here. So let's imagine we have this in place, everything is good and fine too. Okay, so we have something like that, and eventually the crane is coming here, and let me take a look at those mates incident. Well, I can delete those, but you got the idea here. Uh, Remember the crane. It might not have that full precision. Okay, so what uh, what we can do here? So what is probably gonna happen? Well, if the crane it doesn't hit, or if this surface and this surface is it doesn't touch, you'll probably catch it with maybe this surface on this surface. You probably eventually you're gonna have a stuck uh, uh, you're gonna have a stuck uh, piece that will look something like that, uh, let me change one more time the transparency here. So that and that. Okay, so you have this and this, something like that. Okay, so in this scenario you probably you can do anything in terms of well, in terms of automation, except you probably uh, gonna you're probably gonna climb the where this happened, but of course you need to prevent that, or you need to come up with a solution for that. So my idea is to have some type of um, some type of spring between this surface and inside of this uh, bottom piece that I have made. Okay, so you have a little bit of space between this surface here and between this surface here. You have a little bit of space that you can insert inside of that piece. Like I said, uh, you insert some type of spring, so that will when the let's say not this disaster, but when this thing is happening, okay, so when the crane is not hitting uh, exactly uh, where where we want, okay. So when that is happening, you have, let's say, like a automatic backup, when you you, you pull the container up, and eventually this piece will gonna come in the initial position. So did you remember what I said about the gravity, and that this piece it can fall if it doesn't have some type of mechanism that will prevent it to fall. So that will probably happen too on the on the top piece, if we have, for example, a spring that will push this thing up. So you're probably gonna need again or some type of a ball inside here with some kind of spring that pushes in on exactly this surface that I have selected here. Okay, so you're probably gonna have, or you need to implement that uh, um, on this design also. Okay, so things that we need to keep in mind. So we definitely is room for improvement here on the design. So that's probably next thing that we need to think about it. What else can I talk about? The weight of those things. Is what I make here is still under development. Okay, so it's still uh, room for improvement in terms of in terms in terms of weight and resistance here. Um, I can assure you that the middle piece, or this piece that I have selected, or let me jump exactly to this one here. Okay, so this piece here is pretty well designed in terms of weight and resistance. It has somewhere between I believe 4.7, yeah, 4.7 kilos. Okay, so that's that here, and you can from my test here that I made it, um, it can resist to 30 tons. Okay, so a a full container, uh, so it can resist to the weight of a full container. Okay, so if you're not aware of the standard here, but the maximum ISO standard is, I believe, is somewhere 30 tons. I believe is the maximum load on containers. I don't know. It might be containers that have much more than that, but I believe it's 10, 20, and 30, something like that. From what I read, from what I remember at least. So this piece here, like I said, is pretty well done. So if you try to change it, or if you try to manipulate it, try to change it, you may have hard time to come with a better solution, at least for the type of design that I come here. Okay, so it's pretty well done. So believe what I say here, because I did a lot of tests to make this piece. Let's talk a little bit about the others too, or this one and this one. Um, you probably can see the first thing probably you're gonna notice you have a blue uh, uh, surface here, and the and the top one you have a yellow. So let me explain exactly what those things are. Um, when I think when I th- when I think a little bit about that, you know, you have it's just a sign for the personnel, so don't confuse the installation of this thing. Okay, so you, you can translate, or at least in my head, I did something like that. You can translate this blue surface here with the water, with the sea, and with the yellow one you can translate it with the sun, which the sun is always up in the sky, and the sea is always down. And you can prevent it from switching again. So that's, I think that you also need to take in consideration here in terms of you know how you position this type of device. You also can see the unique design, the unique alignment. You can go wrong with installing this piece in a the corner of a container. Okay, so remember what I said about those two surfaces. So let me jump back again, and let's talk a little bit about those two surfaces here, those two, this one and this one. So I believe, and I'm sure and I'm confident that those two pieces uh, you can or you can have room from for improvement in terms of strength, in terms also of, on functionality. So if I open this piece, let me okay, let me open something like that. Okay, so if I open this piece, you probably it's kind of bulking and it's kind of under design, or it still need improvements. You probably see uh, yeah, the mass is 4.3. You can definitely, or I can definitely reduce it and keep the resistance, or keep the strength. So it's something to keep in mind also. Uh, in terms of the inner, those channels, or whatever you can call them, those can easily withstand the force of, um, of the container, container, and when I designed those type of channels, well, I'm thinking about the weight of the container, and of course the friction that is happening between this steel here and eventually the top corner of the container. So I'm pretty confident that the those um those uh, channels here that I made are good, because I did some solid simulation on those. I probably put somewhere about 100 Newton, whatever. I'm not so sure exactly the measurement, but let me check. I'm not so sure exactly where I made it. I believe here. Yeah, I think. Oops, not there. Uh, okay, here. Yeah, here. So let's talk a little bit about that torque here. Let me load it, and let me talk a little bit about that. So I apply a 100 Newton per meter. I believe it's meter square. Okay, so let me edit the definition here so you can see. Yeah, Newton meter. So with that, you can see the result of that thing. So if I show, for example, no, the stress is pretty even. You can see it here. Now you can see the displacement where those things are moved. And if I show the factor of safety, you can see 6.3 or something like that. Well, anyway, what to take away from this? It's pretty it's pretty well done, and what I did here is I'm sure that it will work on what I try to achieve here on this automatically locking design here. In terms of the load of this piece here, you can let me show you some graphs here, or some tests that I did. So remember that I talk about these things. So I did a lot of tests on this one. So if you try to move it, or if you try to improve it, or if you try to improve it, you can, yeah, it's pretty well done like that. So it's very little room for improvement on this piece. Okay, so let me see the you can see the maximum stress where it's happening. um, yep. Well, let me also show the displacement. You can see here it's a pretty even displacement across those top surface. Um, Let me take a look like that. Okay, so you can see it better. Let's look inside. Okay, so it's pretty good down here, and you can also look at the factor of safety. You may have 1.1 or 0.030 anyway, but the what is happening on those surface here. So if we try to remove those inside the surface, you have a factor of safety, I believe three point something, I believe, from my test that I did. So that it might be something about SolidWorks. No, you have 1.1 yeah, just one. So it's a pretty low, but like I say, it might be something about the software, is happening in this point here. Um, it's not a big issue. So if you, like I said, if you try to remove and do another test, you're gonna have above 3 or something like that. So yeah, like I said, it's pretty good down here. So keep in mind that. Also, um, what else can I talk here? So let me take a look here. Mm, so yeah, let's talk a little bit about manufacturability. Okay. Um, so the top piece, and the bottom piece, it's pretty easy to do. Like I said, those two pieces still has room for improvements in terms of strength and the weight. So keep in mind that also. Um, and the those surface here, you can do that with with a milling machine that produce some type of pinions and racks and things like that. So it's not impossible to do it. Where it might be the difficult part. Difficult part is the inside here. Um, is that impossible? Well, it's not. I've seen machines that can do that. So it might be tricky in terms of how you manage to make that inside. But if you talk with a machinist, or the person who is putting the numbers on a machine that is trying to uh, to make those kind of pieces. Um, in terms of that, well, you probably, like I say, if you talk with a machinist, he is definitely sure that you can do that. So it's not impossible. So how we can do that, or how we can approach it, if you take the 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 interior circle here. So I'm selecting this point, hit this point, so this point and this point. So let's imagine those 4 points that I selected. You make a sphere, okay, or a sphere, excuse me, a circle, and you extruded it with that milling machine until this surface, and then you try to move it across those surface, and make this type of design here. So you have all of the measurements on the design. Okay, so if I try to open one more time, this piece, come on, open, and if you go to the, I believe something, is that, I'm not so sure, is that, yeah, probably not that, Intermodal, love 3, okay, so yeah, here is, okay, so you have all the information here for all of those things, and you can also go to the equations and you can check those out. Those are pretty good also. Um, okay, so that's that, and that's information probably for a machinist. Like I said, that person who was working for producing those type of equipment, or the person who, uh, like I said, put the number in a machine and do its job. Okay, so in terms of manufacturability, it's pretty, the middle piece is, it might be probably the trickiest one. Well, the trickiest one, if you try to achieve exactly what I did here. So you probably start from a block of metal, okay, um, and you have a little bit of things to do, but it's not impossible. You know, everything that you see on the middle piece, it's as good as it can be. So not so sure if it's room for improvement. Well, room for improvement, it might be probably the from here to here, the height. Okay, so you probably can extrude this a little bit on the top if if you encounter problems if this thing uh, I didn't talk about that, so let me point that down, so I don't forget. So okay, so uh yeah, so in terms of improvement on the middle piece, yeah, you probably can make this from here to here a little bit taller, so you can prevent the Y rotation. Okay, so let me talk a little bit. I forget that topic. So let me talk a little bit exactly what is the role of the middle piece of. You, you probably understand it until now, but let me talk. So the middle piece is, it has the role to prevent the Y rotation. Okay, so if I move it a little bit here, so you can see that those surface here is touching this surface here, and those type of surface here is preventing the lock of those uh, 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 well, not really prevent the lock, but it helps with the rotation of those things. Okay, so that's the reason why I did like that, and you also need to keep in mind that we manufacture this thing, or when you try to manufacture things, what happened here? Oh my god, not so sure. Um, when you try to make something like that, you of course you need to take in consideration that there are in the world are many containers, and you try to produce, or you try to make a design that is trying to to be as friendly as possible in terms of modification and things like that. Um, so that's one thing here. What else can I say? Well, I'm not so sure exactly what is happening here. Anyway, something strange happened. What else can I talk about? Okay, so let me open one scene here. Oops, not new document. So let me open one scene and container ISO. So I make here a container. Okay, not so sure if I yeah, suppress component and okay. Warmax. Oh yeah, let's delete that. Uh, yeah. So one thing that I need to talk about. Well, there's many things that so many things that I forgot about those. So let me note those. Okay, so one X. Okay, so let me note that so I don't forget to talk about it. Okay, so what I have here is a container, or I should say, is a side it's a size of a container. And here we have, it's pretty much how a container with those four corners are gonna look like. Okay, so let's uh, let's take those things like that. Let me import some insert components, and let's see. Connection to connection system. Okay, so let me import this thing here. Okay, so something like that. And okay, so now you can see probably a little bit better here. Yeah, I need to make some mates here. So let's see. Can do that with that. Okay, so sorry about that. I should do that on my free time here. But let's do here. So between that, and let's do between probably this will work. Concentric. Okay, so that it should work. Let me exit that. Okay, so here is how it's gonna look like, more or less. And they're gonna be installed like that. Okay, so let's put it in place here a little bit, so you can see exactly how we're gonna look like, more or less. Yep. um what I what I need to talk about, yeah, about uh how we can, well, when I designed this piece also, you need to take in consideration that you have some types of I believe it's calling lashing bars or something like that. So let me show you those, how those looks like. Okay. So okay, so they look something like that. Okay, so you need to take in consideration that when you design this type of equipment, when you need to have those lashing bars that eventually you're gonna be installed in those containers, and will prevent, you'll try to lock them as close as possible, uh, or as hard as possible, I should say. Um, if you try to come with another mechanism or another design that will probably take advantage of those corners here, simply prevent if you block those holes here, we probably can't install the lashing bar. So you can't do that, so you can think about that, at least when designing this type of equipment. What else I can say? Let's talk a little bit about how we can prevent this sliding of containers. Okay, so if you um, if you try to prevent the sliding of containers, so let's imagine that we have here one container on this side, one on this side. Well, if you try to prevent the sliding of those two containers from what I made here, you can pretty easily come with a piece. Uh, I'm talking about a middle piece, or a piece that look like that, and it's pretty even, or it's pretty easy to make. I didn't make it yet, but we can make it. So it's pretty easy to make a piece that will prevent the sliding of those containers also. So what I'm saying about that, you try to have you know a piece like that's here, and one that's in this position here, and you design something in between those, something that is industrial, is something that's heavy and can withstand the forces. From what I read, I believe, mm, I'm not so exactly sure, but it's between 180 180 and between 300 k of newtons, so 300.000. Okay, so it's it's a lot. It's about 30 tons of force, about something like that. Yeah. Um, so of course you can of course you can come with a solution for that, for the prevention of sliding of those containers. And of course you can come with a solution that also will work on 4 containers. You just make that and mirror about this side here, and just imagine you have one piece here, one piece here, one piece here, and one piece here, and you have something that is made that you interconnect those things, and you can prevent the sliding of the container. So it's very easy to manufacture. It's very easy to design. I mean, and it's a thing that you can. I believe is an advantage, or from what I have here, we can it can pretty easily be done something like that. Okay, so prevent the sliding, even if you have 2 containers, or even if you have 4. Okay, so you put one on a block of piece here, and you prevent the sliding of 4 containers. So that's that here. What else can I talk about? Let's see. Of course, yeah. About some of disadvantage that this type of system that I made here might have. I talk a little bit about those about the gravity, how he is trying to pull this thing down and eventually fall if you don't lock it. I talk about that ball also, and that spring also, if you remember. Uh, about the container, you probably don't have such precision that you can every time you put this thing uh, at such precision that you all the time you come with you know this uh, this piece to fall into this one like that. Okay, so you achieve that with the spring, and you try to lift this until it hits that ball, and also like that. But I it's also some disadvantage that I didn't talk about, so you should be aware of that. What I did here is it's a pretty good for slide prevent for the locking of the containers, but the locking on for example z-axis, or negative z, or x-axis, okay, or negative x. So pay attention to the what I'm saying here, and those uh, so the logging on those axes, what I did here. Okay, so if you, for example, if you try to achieve a system that will lock also on the y-axis, well, you need to do something different, and I'm gonna talk a little bit about that also. Um, and let's see. Yeah, so what I did here is pretty much locking on the z and the x, and of course the prevention of the sliding, which whatever it might happen on the z on the x. But you can achieve with this design a locking system that will work on the y axis. Okay, so that's unfortunately a limitation of this design, and you should take it. Uh, you know, that's pretty much a limitation. That's it. How we can achieve that? The locking on the y-axis. So, well, my idea is to mm, Idea is to come with well, it's probably and definitely a a costly solution, but it can definitely work. Um, so remember what I say that there are no many containers in the world. I'm not so sure. About 12 million, so not so sure, exactly sure. I read somewhere, but I forgot. So you have a lot of containers. So like I say, the cost is definitely a big factor. Okay, so if you try to come with the solution for the logging on the UI, you definitely need another design, and that design that I'm gonna talk a little bit, just a little bit, is definitely a costly one. So let me explain exactly how we can probably achieve that. I'm not say probably, but you definitely can achieve it. So that well, my idea is to have you probably did you have a car? You probably have or you probably see a braking system of a car. Okay, so my idea is to come with a design that will implement the similar system of how you see on cars, and it's going to be something like that. So you have the DY pressure here. My idea is to make for example, on this piece here, is to make a warm uh, how it's called, warm uh, what is called? I forgot the name. Um, oh my, I believe it's warm. Come on, I forgot that name. Um, not wormhole. We are not on science fiction here. Oh my God, I forget it. Uh, a pinion or a gear. Well, okay, gear. Of course, a gear. One gear. Okay, so I remember. So my idea is to make a worm gear here, um, and eventually on the, for example, on this piece here or on this surface here, on the side, I should say, you also have something like, let's see, something like that. Okay, so my idea is to implement such mechanism that you might find on car, and have it you know you have a warm gear here, and you also have the pinion gear here, and you block that pinion gear with some kind of system that you might find on car or another braking systems. Uh, the car is probably the obvious one. You probably see one. So like I say, you have the one gear here, one pinion. You block that pinion with the system that looks something like that. Okay, and that system is also blocked by a manual. I should say manual, yeah. Um, so it's blocked uh, by hand, and you somehow you do it like let's say, let's imagine that the container of or the top container is having, I'm not sure, let's say it has, or the requirement of the top container, in order to lift it, you need, for example, 10, well, let's say 10 tons of force. So in order to lift the top containers, you need 10 force. So let's imagine this scenario. If you have that type of system with the braking system that I talked about, you can adjust that whenever you install it, and depending of uh, of uh, of the friction here, or depending of what you do here manually, when you start you install that thing, you also prevent the top container for the Y lifting. But of course, this, like I say, probably this scenario will be something like that. You have a container, you need 10 force to lift it, and with that, it's, it's just a scenario. Let's imagine like that. With that braking system, you probably need 11 or 12 or however you might want. So it's definitely a system, but definitely it's definitely a solution, but definitely a solution, or as to say, a blocky solution, or not blocky, but bulky solution, and definitely a costly solution. I'm not so sure if exactly it is worth the investment of making something like that. Um, yeah, you know, maybe a solution, but it's definitely a costly one. Um, but I believe that the Y axis, you probably don't need to look it. Well, I don't want to eat my words, but no, you have. Let's imagine. It depends of also many factors, like the ship, for example. Imagine you have many containers, and let me find that thing. I'm not so sure. I believe I read it somewhere. Um, somewhere. Yeah, there is the measurement of the containers, standard containers. So you have pretty much a lot of dimension, a lot of, max ton, 10, 24, 30 tons, 32. Yeah, different sizes, different categories. This is the containers like that. Those four corners on the top and the bottom side, some dimension for that, also from the corner fittings or dimension here, also some specification. Okay, yeah, so let's imagine there's the ship. Okay, so it's the Y lock. Okay, so let's imagine, yeah, you might need it. Not so sure if, yeah, for example, when it depends of what kind of ship. um, if it's a heavy one, if it's a heavy ship, or if it's a big one, probably can go without the Y. Well, it's less likely that a ship like that will move between up and down like hell, uh, in such a way that it will unlock those systems here that I make it. So I don't want to eat my words here, but no, it's probably not so sure exactly. So that's definitely um, things to consider, and things to keep in mind. And yeah, so what can I say about that? It's a variable, and it's hard to predict it. And of course, it's hard to predict, but like I say, it's depending on the ship that you have. Um, that is might be a variable that you might need to consider. So that's that. Um, yeah. So yep. I think I pretty much talk a little bit what I want to say here. So not so sure if I missed something, but I definitely missed something. But no. Yeah, that's pretty much it. So yeah, remember what I said in this video. It's probably a long one, but just remember. And I'm looking forward to come with with a solution for the those type of logic system. Okay, so yep, so that's pretty much it. So if you have question, just email me, and yep. You can visit my website also, uh, where you find, well, that's a little bit of topic here. You find a lot of things. Well, a lot of things you can find from engineering, sound, programming, and also for a little bit of computer graphics. So that's pretty much it for today. So yeah, I see you on another video. Who knows about what? Maybe programming, or maybe sound, or who knows. So take care. Have a good day.